All right, welcome to The Explainer. Today, we are going to pull back the curtain on some machines we all use probably every single day and uncover the incredible science hiding inside.
I mean, think about it. You hit a button and boom, a perfect copy pops out. It feels like straight up magic, right? But it's not. It all comes down to one single, fundamental, and totally invisible force of physics. Okay, so to really get this, we're going to dive into the two key principles, kind of like the two secret ingredients that make all of this magic happen. First up is something called electrostatics. Now, don't let the fancy name fool you. All it really means is that opposites attract. You know, a positive charge and a negative charge, they pull towards each other. And things with the same charge, well, they push each other away. Simple as that.
Okay, secret number 2. This one is really cool. It's all about a special kind of material called a photoconductor. And this stuff, it has a very interesting property.
And here's the trick, the whole shebang right here. In the dark, this material acts like an insulator. It holds onto an electric charge real tight. But the moment you shine a light on it, bam, it becomes a conductor, and that charge just flows right away. It's basically a light-activated electrical switch. All right, so we've got our two key ideas, opposites attract and this cool light switch material. Let's see how they come together in the OG magic trick, the classic photocopier.
This whole process has a name, by the way. It's called xerography, which is just Greek for dry writing. And it all happens in 5 main steps.
So, deep inside the machine, there's this rotating drum, and that drum is coated with our special photoconductor material. The first thing that happens is a device gives this entire drum a nice, even, positive electrical charge. Think of it like a perfectly smooth blanket of static electricity.
Okay, step 2. You place your document on the glass, right? A super bright light flashes, and an image of your document gets projected onto that charged drum. Now think about it. Only the white parts of your paper reflect light. So what happens where that light hits the drum? Exactly. Wherever the light from the white parts of the page hits the drum, that positive charge disappears. But in the dark areas, you know, the text and images, the charge stays put. And what you're left with is an invisible image made of pure static electricity. It's a perfect electrical blueprint of your document. Okay, now for the fun part. The machine releases a cloud of very fine, negatively charged black powder. We call it toner. And what do we know about opposites? They attract. So this negatively charged toner powder sticks only to those parts of the drum that are still positively charged. All of a sudden, that invisible electrical image becomes a very real, very visible powder image. Okay, that's the photocopier. But this is where things get really cool. A laser printer takes this exact same idea and gives it a high-tech, super precise upgrade.
If you look at them side by side, the core components are pretty much the same. You've still got a photoconducting drum, you've still got toner. The real game changer, the key difference, is how that invisible electrical image gets made in the first place.
See, instead of a big flash of light reflecting an existing document, a laser printer uses a teeny tiny precision laser. This laser scans back and forth across the drum, turning on and off thousands of times a second, basically zapping away the charge to draw the image. It's not copying something, it's creating it from scratch, line by tiny line.
All right, so that's toner and drums, but what about inkjet printers? You know, the ones that spray actual liquid ink? Well, believe it or not, they use that very same invisible force, electrostatics, but in a completely different and frankly just as clever way.
Yeah, forget the drum for a second. An inkjet printer is less like a copier and more like a microscopic, high-precision missile guidance system, but for tiny droplets of ink.
So as these little ink droplets are fired from the nozzle, the printer's brain makes a split-second decision. It zaps each individual droplet with a very specific electric charge. This charge is basically its flight instructions.
Those instructions, that charge, acts like a steering command. The droplets fly between these things called deflection plates, which create an electric field. Now, if a droplet has a strong charge, the field pushes it way off course, right into a little gutter to be recycled. But if it has little or no charge, it flies straight through and lands perfectly on the paper, forming your image dot by dot by dot.
Okay, let's jump back to our photocopier and laser printer for a minute. We've got a perfect powder image on the drum. But how do we get that image off the drum and onto a piece of paper and, you know, make it stick?
Well, first, a sheet of paper is given an even stronger positive charge than the one on the drum. So as it rolls by, it literally yanks that negatively charged toner right off the drum and onto the page. But here's the thing. At this point, it's still just loose powder. If you were to touch it, the whole thing would just smudge into a mess.
So to make it permanent, the paper takes a trip through a final crucial station, a pair of super hot rollers called a diffuser. That toner, it's not just ink, it's actually a type of plastic. And when it hits those hot rollers, it melts instantly. The pressure then squishes that melted plastic deep into the fibers of the paper, fusing it on there for good. And hey, that's also the reason the paper always feels so nice and warm when it comes out of the machine.
So when you really boil it down, whether we're talking about smart dust or guided droplets, it all comes down to one thing: precisely controlling static electricity. It's this single invisible force that's the engine behind it all, turning what's on your screen into something you can actually hold in your hand. It kind of makes you wonder, right? What other powerful invisible forces are hiding in plain sight, powering the technology we use every single day?